All right, so here we go on Thursday the 21st at noon. And what we're going to be doing is we're going to be continuing ecology from yesterday. Yesterday we started the introduction, and the introduction was all about R and K related species, the strategies that they use. Do they produce a ton of offspring in complete ignorance of what the carrying capacity is, or do they produce fewer offspring in kind of recognition of the carrying capacity? And those are the two major strategies. Today we're going to move on and we're going to start talking about what form of selected species they are. And then when you combine those two aspects of their strategy, R or K, and then they're selected, which will have type 1, type 2, and type 3, then you get a better idea of what to expect from their population. So let me make sure that we've got the right thing up here. So for today, we've just got these two things in your folder. The first is the PowerPoint we're going to go over, not very long. The second one will be the Turtle Survivorship document, and that is your assignment. Try to have it in by, let's say, next Tuesday. Gives you a bunch of time. Shouldn't overload you for work. I won't be assigning any more work before then. We'll just be talking about stuff. All right, so our strategies for survival. Now, there's a lot of different ways that organisms can try to make a living. R and K were the major strategies. Now we're going to take a look at what survival type they are. So we're going to have type 1, type 2, and type 3. Type 1 strategists are basically going to have really good survival for most of their lifetime. And then once they reach near the end, we see their mortality rate increase rapidly and they die off. So that's a type 1 strategist. It's generally one of the easiest ones to remember because this is human. We are a type 1 K selected species. We produce offspring relatively slow. Our survival rate is real good until, we reach the last quarter of our life. And then it tends to be less good. A type 2 strategist is going to experience a mortality rate that is more or less constant regardless of their individual age. Whether they are very, very young, middle aged, or old, the chance of them dying is pretty much the same all the way. So it ends up being this is the number of survivors on the Y. This isn't the rate. So the number of survivors reduces pretty steadily, regardless of the number of them at maximum age. Our type 3 strategists are going to experience a lot of mortality very early in life, but once they reach adulthood, their death rate slows down dramatically. So this is quite often a species that will produce a large number of offspring with just the hope that some of them will survive all of those dangers to make it to adulthood. And once they make it to adulthood, they're stable. Then they're going to be pretty good. Right? So this one tends to be our R selected species usually fall into the type 3 style in this because they produce so many offspring. Yeah, of course, a bunch of them are going to die in the first quarter. But after that first quarter, then they can survive for quite a while, assuming nothing else really bad happens. So type 1, type 2, and type 3. Type 1 tend to be not necessarily top predators, but they tend to be usually some form of parental care. That's what ensures the high survival rate in the early life. Type 2 usually is our low scale prey animals, the animals that are a major part of many different food chains in the ecosystem. And then our type threes are usually going to be the things that just try to flood the environment with their young. All right, so pretty straightforward. Type 1 versus type 2 versus type 3, and being able to identify which one an organism is. So, in that regard, it all comes down to war. The war for survival, not like armies technically, but it all comes down to how do these strategies conflict? How does one work against another one? And for that, I just want to go through some pictures with you guys, and I want you to try to identify where do they stand in this competition. Are they types 1, type 2, or type 3? So here's our first round of organisms. So when we take a look at a grasshopper, hopefully you're thinking, like most insects, it's going to fall into a type 3. High mortality rate at the beginning, that generally gets better as they get larger. It's not going to be perfect, and you're going to find some animals, particularly like the grasshopper, that kind of fall in between like a 3 and a 2 because they are also a common prey animal. So, there's a little bit of wiggle room there. What other organism on this do you also think would fall into the type 1, type 2 category? As much as Emily will be unhappy with it, probably our rat that you see there. Rats or mice, whichever one that you want to identify it as, would definitely fall into something along the lines of a type 2. Probably more type 2 than type 1 because they are that common prey animal. What about the jaguar, the bat, and the snake? What do those three all have in common? They're generally considered type 1 strategists. Now, the snake doesn't nearly have the parental care that the other two mammals have, but it does have fangs and venom. And that can make up a big difference in your ability to survive. All right, so let's go away from some of the stuff that we're familiar with and start looking at some of these then. Sure, we've got the robin in the middle. Would a robin be type 1? High survivability when they're young and then less when they're old. Type 2, equal survivability all the way. Or type 3, high mortality in the early years, but then it steadies out for the rest. And hopefully, I don't know how familiar you are with robins, but robins are big prey birds. So they're a type 2. You guys probably don't know what that top thing on the left is. That's a carp, relative of the modern aquarium goldfish. That's a wild carp. You can see they grow enormous. Carp and clams, the one at the top right, also share a survival strategy. Type 1, type 2, or type 3. Type 3. They produce a lot of offspring, tons and tons in the case of a carp. Carp can produce hundreds of thousands of eggs per spawning. Clams and mussels, oysters, things like that can release 1 million eggs every time that they spawn. 1 million. Both of these are expecting their offspring, for the most part, to die. But once they get big enough, there's nothing in fresh water that's going to bother that. And once they get that hard outer shell, their chance for survival goes way up and they stabilize. All right, what about the bottom two? The iguana on the left and the humpback whale on the right. The whale's going to be the easiest one. Type 1, type 2, or type 3. type 1. Because as a mammal, we know mammals tend to care for their youngs. Their youngs? That's not right. They're young. Uh, Whales, in particular, show a lot of parental care, increasing the odds of that child's survival. What about an iguana? They don't live here, so you may not be familiar with them. Iguana falls somewhere between 2 and 3. Iguanas are prey animals for a lot of large predatory birds. But, kind of like a type 3, once that iguana hits a certain size, it's relatively safe. Once they hit a solid 20 pounds, most predators won't bother with them because there are better, safer options, the smaller the iguanas. But at the same point, they still do get predated upon pretty regularly. So, your assignment today is to take a look at the baby sea turtle and try to identify and follow through. It's a very short case study. I think the case study itself is all of 2 pages. Try to figure out what are its survival strategies. Type 1, type 2, type 3. K selected or R selected. As you guys work through the paper, it's pretty straightforward, although it apparently takes a while to load. So, the little story bit here comes down. There's a couple of questions. They want you to view a video. You can scan this QR code in order to see it, or you can look it up. It's not too terribly difficult. Then the survivorship curve. So this is going to be more or less the hard part, and the calculations aren't bad. But doing a graph can be. So just understand, I'm accepting a great deal of flexibility in the graph. If you want to get like a picture of graph paper online and do it on that, that's fine too. But if you're gonna freehand it on this, I can accept that. That'll work. And then finally, it finishes up going into a governmental aspect because there's a lot of stuff to keep in mind with the natural environments that a nation may need for what sort of laws they enact in order to protect them. So that's it. There's a grand total of 10 questions. It's not long, it's not super hard. Most of it is honestly just a lot of empty space. And I think that you guys should be able to handle that pretty easily. So, hopefully that helps. Tomorrow, we'll talk a little bit more. We'll start talking about energy flow through an ecosystem and how the food webs and therefore the KR1, 2, and 3 strategies kind of influence and where they fall when we look at modern food webs, food pyramids, energy flow diagrams, and stuff like that. And then we'll be good. Remember, final projects are due not tomorrow, Friday, but the following Friday. Any questions, comments, anything like that, please make sure to send them to me. Otherwise, you guys got your stuff. I hope everyone has a great day. Stay safe, stay healthy.